Yes, I welcome you back to our class this afternoon. Yesterday we were talking about fluorescent substances that has the ability to fluorescent. And in our last lecture series, which is yesterday, we talked about quenching phenomenon. That there are what we call quenchers in fluorescent techniques, whereby the intensity of the fluorescent substance decreases, and we're able to establish the different types of fluorescent quenchers. Quench, we said dynamic, which is also called collisional quenching. We talked about static quenching. We talked about resonant energy transfer, and we also talked about self-quenching and gave various examples in our second series of this very lecture. Now, it is of importance to know why quenching matters. Quenching matters in the sense that it helps to understand the molecular interaction. Two, it also prevents a false low reading in fluorescence study. In case you are being asked why quenches, why does it matter in fluorescent techniques? I said one, to understand molecular interaction. Number two is to prevent false low reading in fluorescent study. This very afternoon, I want us to move on to another instrument of interest in clinical chemistry, termed flame photometry. Flame photometer, is an instrument. Flame photometer. It employs the use of flame photometry techniques. What is it all about? It's an analytical techniques that helps to detect and measure the concentration of certain metals ion by analyzing the light emitted when these metals are introduced to a flame. Analytical techniques that helps to detect the concentrations of metallic ions by analyzing the emitted light when these ions are subjected to flame. That is flame photometry. The metals we are talking about here is the alkaline earth metals. Take your mind back to your periodic table of elements. You understand what we mean by alkaline earth metals. Here we are talking about sodium, potassium, calcium, and some other elements. What is the principle employed? Let me recast this flame photometry again. A metal is subjected to a flame. The intensity of that flame is directly proportional to the amount of concentration of these metals present in the flame. Do you understand that? That is flame photometry. Of what importance is flame photometry in clinical chemistry? We use it to measure the level of sodium, the level of potassium, the level of chloride. You can use it for you can use it for sodium, potassium, mainly, especially. In addition, you can add lithium. Please understand, the ability for this to measure various substances depend on the monochromatic light, depends on the filter. I repeat again, alkaline earth metal like sodium, potassium, calcium, it can help to measure this metal. It can even measure lithium, and it can also measure barium. It all depends on the filter in that very machine. Now quickly let's look at the principle. When this sample, let's for example your blood sample, remember it contains some electrolytes we have just mentioned, charges, positive and negative charges, especially the positive charge. When that sample is sprayed into a flame, what happens? The heat excites the metal in that ion and raise the energy level to a higher ground. As the electron is trying to return back to the ground state, there is going to be emission of energy in visible region in form of a visible light. And the wavelength of this emitted light is the characteristics of the element. Characteristics of that very element. And the intensity is proportional to the amount of element present in that very sample. Now quickly we look at the components of flame photometer. At least there is one in the lab there. I want you to take a look at that very flame photometer when you have an opportunity. Meet up with the scientists in the lab and tell them, please can I have a look into this very flame photometer to know the very component. Number one of the component we call it nebulizer. Nebulizer as one of the components helps to convert, help to nebulize this very sample and turn it into a liquid mist and turn it into a fine mist. Nebulizer helps you to make that very sample in an aerosoic manner. Yes, so that it becomes an aerosol and spray it into the flame. That is what nebulizer does in flame photometer. Then we have the burner himself, which is the flame itself. That is the thermal energy that helps to excite the metal ion present in the sample. Another thing there is the filter called the monochromator, which helps to select a specific wavelength of the emitted light. And not only that, we have the detector, which helps to measure the light intensity. Just like in the previous class I said, check on photomultiplier tube. That is one example of a detector. And we have a radar device, the meter, that helps to display the result. Once sample is injected into flame photometer and there is nebulization of the sample is mixed by a gas, it turning into a aerosol form, whereby when that gas is ignited, there is an energy. There is this thermal energy helps to convert that very aerosol sample into a higher energy level. While returning to the ground state, the emitted light is equivalent to the emitted light is directly proportional now to the concentration of what is present in that very sample. Like we're using the flame photometer, we can measure sodium at wavelength of 589, which is yellow flame. It gives a yellow flame. Potassium at 766, it gives violet color. Calcium at 622, it gives a brick red. Lithium at 670, it gives a crimson color, while the barium at 553, it gives a green coloration. The application of flame photometry, number one, it helps to measure sodium, potassium, calcium, lithium, barium, and other elements present, alkaline earth metals present in sample. Number two, it helps to check the quality and purity of our drugs, that is in pharmaceutical industry. Not only that, it helps to check the quality of salt and mineral content in food industry. Does it have advantage? Yes. Number one, the advantage is that it is simple to use and it is fast. Number two, it is inexpensive. Number three, it is highly specific for alkaline and alkaline earth metals. And also it is suitable for large sample throughput, which means you can use it for a large sample. But with the advent of science, we cannot measure electrolyte with the help of what? ion selective electrode, but there are limitations in using flame photometer. What are these limitations? One, it cannot identify non-metallic element, non-metallic, it cannot. Two, it has interference with other ions. Three, there is always low sensitivity compared when you are using atomic absorption spectrophotoscopy, which is AAS. And not only that, it requires precise flame control for accuracy. These are some of the limitations one can encounter while using flame photometry. Now, it is of interest to know that there is need for proper calibration of flame photometry in order to have an accurate result. And when that is done, you'll be able to obtain a calibration curve, and the sample emission intensity can be compared with this very curve to determine the concentration of substance in that very sample. I hope that is clear. Now I want us to move again to another instrument called, another analytical technique called conductometry. Conductometry. What is conductometry? From the word conductor. From the word conductor, the movement of energy through a conductive material, which means this instrument have ability to conduct an electricity. That is it. Conductometry is simply put saying how a solution can conduct electricity when, depending on the number and mobility of the ion. Now, therefore, what is conductometry? It's an electrochemical analysis method that measures the electrical conductivity of a solution to determine the concentration or behavior of ionic species during a chemical reaction in a solution. During a chemical reaction in solution, which means you are trying to measure the ability of how materials, especially solution, conduct electricity. Does it have a principle governing it? Yes, there is. This principle is saying that when an ion in a solution carry current, the more the ion present in that very solution, the more the conductivity of that very solution during chemical reaction. That is just the basic principle. The higher the ion, the higher the ability of that very solution to carry current. Now, quickly, I can say is part of electrolysis. Electrolysis. When this very electrolyte in that solution is charged, you see an electric current is passed through. It carries that very current across the poles, just like what we have in electrophoretic procedure, which means the alkaline is charged, the buffer is charged, and is able to carry electric current across the pole. So by determining the conductivity, we'll be able to monitor reactions, we'll be able to get the endpoint of titrations, and not only that, we'll be able to analyze salt and acid-base concentration. What are the parameters when we are looking at this conductivity? We are looking at conductance. And conductant is given by an equation which is related to 1 all over resistance. That is the formula of conductance. What are the applications of conductometry? Please, I want us to take it one after the other. What do we use conductometry for? Of what importance does it have in the laboratory? Number one is that it helps in acid-base titration. Number two, it helps in water purity testing. Number three, it helps to determine the presence of ionic species present in a solution. It has advantage One of the advantages is simple and it is fast. Number two, no need for indicator. There is no need for indicator while you are carrying out conductometry. Compare when you are carrying out ordinary titration, where you require an indicator. Number three, is useful even for every dilute solution and high sensitivity to changes in ion concentration. But there are limitations of conductometry. One of the limitations of conductometry is it is affected by temperature. It is affected by temperature. Number two, these ions that carry charges across this very solution can be coated on the membrane potential of the conductor, thereby imparting the accuracy of the result. That is electric or electrode foiling. It can cause electrode foiling. And these are some of the limitations that can be encountered while using conductometry. Now, quickly we look at what is called osmometry. Osmometry is a technique that is used to measure the osmolality of a solution. Osmolality of a solution, it is the concentration of osmotically active particles. In case you are asked, what is osmolality? The concentration of osmotically active particles. Osmotically active particles in a solution per kilogram of our very solvent. It can be water, which means the amount of solute present in a solution determine the concentration of that very solution. Therefore, it's of interest to measure the concentration of a solution using a technique called osmometry, or an instrument called osmometer. What is the principle? It's based on the principle that the presence of a solute affects the colligative property of a solution. That is the principle. Now, what are colligative property of a solution? Number one, freezing point depression. Number two, boiling point elevation. Number three, vapor pressure lowering. Number four, osmotic pressure increase. These are the basic colligative property of a solution, which means the presence of a solute. Please, let's listen. The presence of a solute in a solution can decrease the freezing point of a solution. Yes, it can decrease the freezing point. It can decrease the freezing point, which means if I add a substance to a water, the freezing point of that very water become lower because the solute have changed this colligative property. Also the same thing, if I add solute to a water, for example, it's going to take time for that solution to boil, which means there is presence of impurity. By way of doing that, there's going to be an increase in boiling point, even above 100 degrees. Even above 100 degrees, we all know that pure water, a clean water, boils at 100 degrees. But the presence of a solute in that water can even increase it to 150, it will not boil. That is what we are talking about, which means the presence of impurity have changed that colligative property. Number three is that vapor pressure is one of the colligative properties. The presence of solute in a solution lower the vapor pressure and also increases the osmotic pressure. Now, what are the types of osmometer we have? We have freezing point osmometer, vapor pressure osmometer, membrane osmometer, and all these osmometers have their own uses. One, the freezing point osmometer is used to measure plasma and urine, even in the laboratory. It helps to measure that. It measures solutes, how solute lower the freezing point of water. Vapor pressure measures how solute lower the vapor pressure of water. And also osmotic pressure, membrane osmometer measures osmotic pressure directly across the semi-permeable membrane. Now, what are the clinical importance of osmometry? One, to evaluate fluid balance and electrolyte status. Number two, it helps to diagnose poisonings or drug overdose. Number three, it helps to detect osmolar gap, the difference between the measured osmo and the calculated osmolality. Number four, it helps to assess renal function and diabetic insipidus. These are importance of what? Osmometry. What samples can we use in osmometry? Number one, we can use serum and plasma, we can use CSF, we can use urine. Now, let's quickly look at some of the ranges of some osmometer in medicine, in laboratory medicine. Your plasma is concentrated at the level of 275 to 295 milliosmo per kg. Milliosmo per kg. That is the concentration of the presence of solute in your blood. 275 to 295 milliosmo per kg. When this concentration is higher than this, it rather helps to drag out water from your system and hence causing what we call hypotonic state. Hypertonic state, because there is excess solute in the system, and that alone can result to an individual being dehydrated and such individual passing out excess of urine, which you can see in the case of diabetic insipidus. In case of urine, when it is higher than 850, it can also cause dehydration. And in the case of CSF, when the osmolality is higher than 300, it can affect the brain cell. It can lead to shrinkage of the brain neurons, of the brain cells, thereby leading to brain damage. Now, I want to take note of that. Now, the presence of solute in any solution affects the colligative property. Hence, we want to look at how it affects the colligative property, which I said earlier. That number one, it decreases the vapor pressure. The more solutes are present in a solvent, the vapor pressure or the evaporation decreases, hence less evaporation, and that is being covered by a law called Rayot law. Was able to cover that. Now, in cases of boiling point, I said presence of a solute in a solvent increases the boiling point. When the vapor pressure reaches its atmospheric pressure, hence the vapor pressure lowered by solute, and a high temperature is needed to reach a boiling point. That is how it affects. Now, let me repeat that again. Boiling occurs when a vapor pressure equals atmospheric pressure. That is the point at which boiling occurs. When vapor pressure is now lowered because of impurity or because of solute in that very solution, what happens? You are going to need more temperature to reach the boiling point. Hence, solute in a solution increases the boiling point. Not only that, it causes, okay, I said that earlier, it affects boiling point and it lowers the vapor pressure. It lowers the vapor pressure. Now, let's come to look at the freezing point. which I have already explained, that freezing point of a solution in the presence of a solute, it decreases. It decreases. Solute particles will not interfere with the formation of solid structure, which is crystal lattice of that very solvent, thereby making it harder for the solvent to do what? To freeze. So the temperature must be lower for it to what? To solidify. That's what we are talking about. Try and experiment what we are talking about. Put a clean water into a bottle and a dirty water into a bottle and put in a freezer and check which will solidify first. Which will solidify. You will understand from here that the water that is impure is going to the water that is impure will need more lower temperature for it to where? To solidify. Hence there is decrease of the freezing point of that very water. Now let's move further by looking at scenarios, medical scenarios in which osmometry is of importance. Number one medical scenario, we use it as in practice in form of clinical osmometer used in checking the freezing point depression to measure the osmolality of our body fluid, plasma, urine, CSF. We use it to measure the concentration of these very substances in our blood. Now, not only that, it helps to detect when there is dehydration. You know, I said that increase in solute in your system can cause dehydration. You can drag out water from the cell, making your blood to be hypertonic. I also said that it affects the osmotic pressure by increasing it, by increasing your osmotic pressure. You understand from the days of our secondary school that osmosis is the movement of water from a lower concentration to a region of a higher concentration through a semi-permeable membrane. So also our body system is divided into compartments, the ICF, ECF, and the ISF. When there is higher concentration of a solute in one compartment, there is tendency of movement of water across the semi-permeable membrane, which means the higher the solute in your ECF, the higher the water will drag out from the cell, making your cell to undergo shrinkage, and that can even lead to cell death when a cell undergo shrinkage. Now, another thing that is of interest is that this osmotic membrane osmometer, we can also use it to check osmotic diuretic. There are drugs that can make you to pass out water. Drugs like mannitol increases osmotic pressure in renal tubules, dragging out water to reduce even intracranial and intraocular pressure. And not only that, we also use it to check parental nutritions. Osmotic pressure helps to determine the safety of administering high glucose solution through peripheral or central line. Now, quickly before I round up this very series, we'll look at a summary. I put a summary table to you on how colligative property of a solution is affected by the presence of a solute. Vapor pressure will decrease, boiling point will increase, freezing point will decrease, osmotic pressure will increase. Yes, it will increase. Please, I want you to take note of this. In this very class, I'm rounding up. Pay attention to details of what that has been mentioned, listen to it over and over, and get the best from this very series. I see you in my next class. Thank you.